In this video, we're going to review some topics and then also talk about the way that these questions have been asked on the AP exam. An insurance company believes that the more time an agent spends with a potential client, the more likely it is that the client will buy a policy. The average number of minutes for 15 agents and their number of sales is recorded. So you can see the X here is the number of minutes and deviation for that, number of sales and deviation, and the correlation. So, which of the variables is explanatory? Well, I'm just going to kind of do this with a circle. It's going to be the average number of minutes. That is going to be our explanatory variable. Okay, the number of minutes, and the response, of course, is the sales. Finding the least squares regression line. Well, by hand, remember these formulas, that slope is equal to the correlation times S of y over S of x. And, our equations are always y equals a plus bx. So if I'm solving for a, I'm solving for that y-intercept, it's going to be a is equal to, and we use the means, y bar minus b times x bar. Okay, now if you've forgotten that, you're unsure of that, go back and watch the previous video where we showed that, or where I went through that. But I'm going to kind of move through this kind of quickly. So for b, the slope, that's going to be equal to our correlation, 0.884, multiplied by S of y, which was 3.5, over S of x, which is 4.1. It comes out to be 0.75. Okay, so now I know my, I know my slope, and to get the intercept, I do a equals y bar, so 12, minus 0.75 times x bar, which was 25. Sorry, I'm kind of creeping into that wording there. This comes out to be negative 6.75. Okay? So now, using kind of that correct notation, I've got sales hat, number of sales, equals negative 6.75 plus 0.75 times minutes, or number of minutes, okay? Now, predicting for the number of policy sales for an agent, okay, so this says they average 30 minutes, so we would say it's going to be negative 6.75 plus 0.75 multiplied by 30 minutes. And that comes out to be, if you typed it in, 15.75. And this gives me a great chance to talk about the way things like this are graded on the AP exam, in that you must show work. You should not be typing stuff in and not telling the grader what you're typing in. You must show this work in order to get credit on the AP exam, okay? So don't just say the answer. Now, in terms of interpret the slope, the y-intercept, and r squared, I kind of pre-did this because it's a little bit long to talk about. So let me put this where we can read it. And I'm sorry, when I typed this, I maybe did a little bit different rounding than I did on this. So slope, for each additional minute an agent spends with a client, it is predicted that the amount of sales will go up by 0.75. For y-intercept, if an agent spends 0 minutes with a client, the agent is predicted to make, so again, I can change this because I took it off the calculator where I had not rounded. So let me put this. And finally, if you calculate r squared, so if you go up here and you just square this number, you get 0.781. So 78.1% of the variation in sales can be explained by the variation in the number of minutes. Okay, so again, you've got your meaning of slope here. Remember the word addition for each additional explanatory, what's predicted to happen in response. For the y-intercept, if the explanatory is 0, what's predicted to happen in the response. And the variation in the response that can be explained by variation in the explanatory. All right, let's look at an AP question. So, one of the ways the AP exam has asked these questions the past couple of years is with computer output. And it's a pretty easy thing to read. It's a little confusing at first. And the program that the AP exam uses is what's called Minitab. You can see this Minitab output right here. What we need to be able to find is the slope and the y-intercept and the values s and r squared. The AP exam, as I said, uses Minitab, but one of the more popular statistical programs you can use now that's free online is R, or R Studio, and the output for that looks almost the same. So it's kind of a standard output format, and that's why the AP exam wants you to look at it. You can get all the information you need, and then you can talk about it, and it's kind of an industry standard kind of readout. So the output, under coefficients, there's always a constant coefficient, and this is the y-intercept. And then there's always the explanatory variable next to the slope. Okay. Now, you're given r squared. Don't worry about this r squared adjusted, but you're given r squared. And the standard deviation of residuals, remember this, we talked about in the previous video, this is your typical distance between the line and the actual points. Okay, and that typical word is kind of important. It's more encompassing than average. So it's a typical distance between the line and the data points. Now, these other things, these all have meaning that we will explore later in this course when we start doing hypothesis testing. But for right now, these are the only things we really need. Let's look at an AP question. Windmills generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amps per one particular windmill. For the windmill, measurements were taken on 25 randomly selected days, and the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data, which were from 10 miles per hour to 40 miles per hour. Okay, so you can see our output, and the first question is use the computer output to determine the equation of the least squares regression line. Okay, so the first thing we've got to recognize is electricity production is what's being predicted here. So we're going to write that, and just in the interest of space and time, I may do some shortening up. So electricity. Spelling it wrong, I apologize. Production, I'm just going to write this. Production hat is equal to, so our coefficient, our constant coefficient is our y-intercept. So we're going to write 0.137 plus. Then we've got our slope next to the explanatory. So we're going to write 0.24, and again, I'm going to write WV. You'd want to write wind velocity, but I'm just out of space. Okay, so make sure you do the hat, make sure you write these in words. How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 than on a day when it's 15? Well, let's plug 25 in, so 0.137 plus 0.24 times 25. And we'll get an answer. And we'll also do 0.137 plus 0.24 times 15. And we'll get an answer. And then we can find the difference. All right. So the answers are 6.137 for this and 3.737 for this. So if you do the difference, 6.137 minus 3.737, that gives you 2.4. Okay, that's the difference. And finally, what proportion of the variation in electricity production is explained by the linear relationship? Well, this is r squared. Okay. So all we need to do here is report the r squared value. And it did say proportion, not percent, so we can just say that. But that is the proportion of variation in wind and electricity production explained by wind velocity. So this is an entire AP question. It's pretty short. It wouldn't take you very long to do. Make sure you'd show work and use correct notation. But other than that, this one would be a very, very fast question. You'd want to get all the points on.